Hello guys, welcome back to my channel. So today we are going to look into two specific libraries in Python. One is Pandas and another one is Matplotlib. So Pandas is basically used for data analysis. Like whenever you load a data set, you can load it in the format of data frames, and then you can apply whatever the operations that you want on the columns and rows of the data frames. So this is going to be a like what are all the functions on a high level we have with Pandas. And Matplotlib, basically how do you actually plot graphs with x and y axis, and what are the other operations that you have, and what are all the customizations that you could do with the graph. All those things are will be present in this lecture. So basically I'll just go through this snippet of code that I have where I have in the Jupyter notebook. Let's get started. Pandas Matplotlib. Basically, how do you install it? Just like any other library, you do a pip install followed by the library name pandas, pip install pandas and Matplotlib, used for data cleaning and analysis task. Okay, so pandas. This is a dictionary. Okay, Python dictionary, which I have discussed all the data structures in the first lecture of this playlist. You can go to that video and refer to that. I will even leave a box here. So basically, this is a dictionary where cities is my key and population is my key, and I have the city names here and the population of each of the cities in this particular thing. I want to convert this as a data frame. Basically, data frame is nothing but a structured way of looking at the data, some kind of a Excel sheet or some kind of contains rows and columns. If you see here, this dictionary is taken as input to this data frame. With Pandas data frame, I was able to build this thing called a cities and populations. I just got mapped properly. This is basically a table that you see here. You have the data here. Okay. So next is Pandas series from a list, which means pd.series 1 comma 7 comma 2. This is a list, and I'm creating a series using this list of values. Zeroth index is 1, 2, and the second index is 2. Is all of data type of int 64. Okay, 64 is nothing but the 64 bit. Next is labeling the data frame. I have a list of values. A is equal to 172. Next is myvar is equal to pd.series, which means taking this as input here. Pd.series of this particular list, index x, y, z, which means x should map to the first element, y should map to the second element, z should map to the third element. Okay, so if you see here, after doing that, I have got the result response in the specific labels that I have mentioned here for these values. Okay, that is what this is. Next is simple pandas series from a dictionary. Temperature. I have something called as a temperature, and where this is a these are all the keys these are all the keys, and this is the temperature series where I'm passing this particular temperature dictionary as an input to this, and I'm only selecting some specific indexes. So what happens is when I print this particular temperature series, it only prints the values with respect to Monday, Wednesday, and Friday. Leaves out this Tuesday and Thursday and prints only these three values. Okay, we could see the values here. Next is referring to specific row indexes. This is a dictionary again consisting of calories and duration. I'm converting this as a data frame, and then I'm printing it. Okay. Next, after printing it, .loc.0. What does that mean? Okay. Basically printing a data frame. This is the result. When I do a df.loc, what is the result that you see? You see 320 and 4, which is the first values of this particular data set. Okay. Next is how do you read a data from a CSV file? We have a simple function called as pd.readCSV. This is a CSV file somewhere available on the internet. So I just given the link and it loads the CSV file right from there. And this is how the data frame actually looks like. Okay. Next is a read JSON file. How do you read a JSON file? This is learner, some kind of a JSON file that I found, random file that I found on the internet. Once I load it, once again you could see a well tabularized structured thing that is present here. Next is what are all the general functions, very commonly used functions in pandas data frames. Okay, there are a lot of others as well, but I will explain it when I'm going to do the data analysis stuff there. Okay, if you see here, df.describe, what does this give me? It tells me this is a okay, df.describe, df.info, df.index. These are some of the functions which helps me to understand the data frame and its meta information of the data frame in much clear format for me to do some any kind of further processes. Okay, next is index publication version. So okay, this is all fine. This is all the output of whatever df index was it. Okay, so if you see here, index publication version is the index. As of now, the data frame points to the specific JSON file where index is published and version. Okay, that is what is being displayed here as index as well. Next is, these are all some general functions. Simple dictionary is declared. I'm just printing the dictionary. You'll see the output there down. Next is I have the data frame attributes. Shape of the data frame, which tells me the number of columns and rows. Length of the data frame tells me the number of rows. df.columns, what are all the column attributes that is present? It gives me a list of column attributes. Next is data types of columns. df.dtypes, what are all the data types that are in the data frame? Okay. So accessing the column, how do you access a specific column? Df of name. Okay. For example, there is a data frame like this, where there is name, scores, like that. Assume this is a data frame. How do you index this column? You just do df of name. That way you can just index this column. Okay. Next is accessing a column. How do you access a column? So it's the same, accessing, indexing, everything is same. So if you see here df, this is another two, which means I'm trying to select two different multiple columns. Okay, two different columns from the same data frame. Okay. Next is, how do I access a row? Okay, iLoc, this is a function which you could use. Access the first row. This gives me the result of the first row. Same way, this gives the result of the rows from the first to third. Here, if you see, it is mentioned as 1 is to 3, not 0 is to 3. Okay, the first row is indexed as 1, 0. Second row is indexed as 1. Okay, this is an indexing. So when it's 1 is to 3, it gives me the rows from second row to the third row. Okay, the data set does not include this row. Understood? Next is doing a simple filter operation here, accessing rows based on the condition. Okay, df of age greater than 30. Consider I have a data frame where there is name, there is age. Okay, so I have different names here and different ages here, and I have the numbers will be different here as well, right, for each and every person. So when I put this df of age of 30, it only gives me the data where the age is more than 30. Okay, and excludes all the other data rows in the data frame. Next is adding a new column to the data frame. Okay, this is the specific column called as df.city, and this is the list of values that is going inside for the specific df.city column, data frame column. Okay, and once I print it, I get the actual results of whatever it is. I have the results printed here. I will show them one by one. Okay, and next is dropping a column. How do you actually remove a column from a data frame? So df.drop columns is equal to occupation, in place is equal to true. What does this in place is equal to true? For example, if I don't mention this, df.drop column is equal to, so assume I have not mentioned this and I have only done this, and I move to the next step to print df.columns. It would also print occupation in the list of columns. But if I make in place is equal to true, it is assigned by removing, after removing the column, it also assigns the data frame that this particular column is totally removed. But if it is false, no, it is actually present in the data frame and it is not actually removed. Okay, df.drop and mention the list of columns that you want to drop from the data frame. Next is renaming the data frame. For example, df.rename columns. I want to rename the column called as name with full name. I want to rename the column called as gender with sex. Okay, so that is how I do the renaming stuff, and in place is equal to true. The same thing, whatever I mentioned, it assigns the things to data frame rather than just having it on the RAM. Next is sorting the data frame. Okay, so assume the same way, name, age, I have a data frame, and here I have to sort by age. How do I do it? Sort values, df.sort values by what? By the specific column name that you want to sort. So it sorts based on the age. Next is missing data. So how do you handle a missing data? For example, here you see the dictionary that is defined, and missing data, I'm creating a data frame from the dictionary that is defined. None, or you have to be know about this none and different variables present here. Print the data frame, print the missing index, handling the missing index. I'm doing a drop NA, which means dropping the rows with the missing values. Okay, it drops the rows that has missing values. Fill NA, which means name will be filled with unknown, age will be filled with the values of the mean of the ages. Okay, this is how we are just filling the missing values in the data frame with some logics using this fill NA function. Concatenation of a data frame. There are two things. One is concatenation and another one is append function. So what is the difference between concatenating and append function? So append function, what it does is you have two data frames, appends the specific data frame to the end of the next data frame. What is concatenate function? With concatenate function, you have a lot of does the same thing, but ultimately there are some customizations that is available along with the concatenate function. But comparatively, the time complexity of concatenation is little higher than appending. Okay, there are versions. I'm not sure about the versions with Python 3.8 and 3.9. There is one specific version where you can't use append functionality. So concatenation has become a general norm nowadays. Okay. Next is I have a dictionary here defined as city population. Creating a dictionary again, merging the actual df which was defined here with based on the data that I have created here, merging both of them, and I'm getting the final df here. Okay, and I'm storing it here. Finally, if I want to save it as a csv file, just do df dot if you see here, I have done this df.tocsv and put the csv file name that I want to save, and index is equal to false. Index is equal to false in the sense the value of the indexes will not be set if I'm saving the CSV file. If it is true, it will be set as indexes. Okay, the indexes will be present in the final CSV that's getting stored. So same way we know how to read a CSV file as well, like we have done it before in the previous lectures as well. Okay, so these are all the outputs that you see for the code that is all present here. Next is, let's move down. The next is the Matplotlib library. So with pandas, there are even other functionalities. We will cover them all actually when we are going to do some data analysis. Okay. Next is Matplotlib, basically used for plotting the values in a graph. Okay, and has a lot of customizable actions that you could do on the graph. Okay, I have same way pip install, then do a import matplotlib.pyplot, and doing a import numpy as well. Maybe there is the need for this library to do some mathematical computations. That is why this particular library is being implemented. X points is equal to np.array, y points is equal to np.array, x comma y axis plt.plot x points comma y point. So I'm plotting the x axis plot. I'm passing the value of the x axis. Okay, it has the values from 0 to 6. It has the values from 0 to 250. I am passing x axis and y axis values to this plot function and doing a plot.show to see the specific graph. Okay, same way rings. What is rings? Okay, instead of actually drawing the graph, I can mention this is the kind of ring that I wanted to mention, and it will just give me the ring of these two data points alone. Okay, next is same number of points in both the axes, x points, y points, 1 3 2 8 6 1 and 8 10. That is how you read it, right? 1 comma 3 is a one coordinate and 2 comma 8 is the next coordinate, something like that. Okay, so plot function takes x axis and y axis both and show we are just going to print it. You see the values getting plotted here. So what is the first data point? 1 comma 3. So 1 comma 3 is somewhere around here, 1 3, right? 1 comma 3. Next is 2 comma 8, which means 2 is present here, and 2 comma 8. Okay, next is I have 6 comma 1, which is 6 and 1 here. Okay, 8 comma 10, you know 8 comma 10. Okay, x comma y values. So this is so. Next is markers. What is markers? Okay, here if you see in this graph, there is no points that's actually marking this. Rather, it's just a peak of turn that I could identify that this is a point it's trying to graph. But with the markers, I can just put some dots and make it like this. So you can use this parameter marker here. Next is the same way, the another marker, you can use an asterisk symbol, or there are a lot of other symbols as well which you could use as a marker. You could just go to the Google and check for the things that you need and use them here. Okay. Next is plt dot plot y points, marker is equal to O, ms is equal to 20, and mec is equal to r. Okay, which means ms determines the size of these marker points. Okay, and mec is the color that is red, which I have mentioned R, and you can see the red color here, and I'm asking a marker to be of O. Okay, next is dotted and dashed lines. I can choose between having dotted lines and dashed lines. Here I have mentioned dotted, so I have got a dotted line here. If I have mentioned it as dashed in this parameter, I would be getting something like a dashed line to plot this graph. What this hot pink means, like this graph, if you see, the lines are in pink color. That is what hot pink I have mentioned earlier. You have the ability to do that customization as well. Next is labels. Study hours and exam scores are the two different lists that have been defined. Plt.plot, study hours, exam hours, markers is O, which is the marker which will come here, the print mark, and line style is something like a line graph is what being mentioned here. I'm going to plot this. That is what means here. Next is I'm mentioning a font type. I'm also able to mention the X label and Y label. What does this X label and Y label mean? When there is a X axis and this is Y axis, right, and this is X axis, there must be a name associated with this based on the data. So that name can be assigned with the help of X label and Y label. And what does this title mean? This title means that I can have the title of this whole graph, which means LOC left, which means locate this title to the left side of the specific graph is what it means. Okay. Also, if you see here, I have used something called as okay, that is not visible. Okay, there are this is a vertical kind of lines, grid lines, right? I can either have vertical kind of grid lines, or I can have both of them, or I can have only the horizontal grid lines. We have we have that with Matplotlib. Okay, next is I'm declaring two different arrays. One is X and another one is Y. Here plt.subplot 1, 2, 1. What does this mean? Okay, so assume this is the area that you are going to have the graph. Okay, and you want to have multiple graphs within this area. How do you mention this? Okay, one row. Okay, basically I only wanted to have one row. I don't want multiple rows, which means here the data, this is only one row is present here. Okay, so with this one row I want two columns. Okay, two columns, and the first plot, this is the first plot. The first plot will come here and second plot will go here. So if you see here, I want one row, two plots, one row with two columns, and first plot. Okay, the first plot will come here. Okay, so whatever the data that's here, it will just go and populate here. Same way, whatever the data that is present in the other half, it goes and populates in this region. Okay, next is scatter plot. Day 1, the age and then speed of the 13 cars, x, y, np dot array, where I have defined the list of values, and doing a scatter. What happens? 5, 99, 8, 7, 86, 8, 87. These are all the coordinate values that you have. And now when you try to do a plt scatter, what happens is you plot them with different colors on the graph. Okay, we have the customizability to actually assign each and every color to each and every dot in this graph as well. Okay, next is color map. Cities, I have defined all the cities here. Next is I have the days here, Monday to the Sunday. Next is this is the temperature data. I understand all these 5 different places have different kinds of climate, but this data is something like assumption, doesn't very closely resonate with the temperature of each of cities. Okay, this is a random data that I have collected against these cities. Okay, so if you see here, this is defined like this here, and I have got it. Now I'm generating a heat map. Okay, plt.im show, which means that image show temperature data. I'm passing this temperature data here, and I'm also mentioning the color here. Add a color bar with the heat map data, and mention the temperature degree Celsius, basically the temperature which you see here. Okay, x-ticks np arrange length of the days. With respect to the x-axis and y-axis, I have mentioned what should be present, and I'm adding a title which is basically this one, and I'm adding a x-axis as days and y-axis as the cities. Okay, x is days and y is cities. Okay, so if you see here, this is the color map. Okay, this is a heat map and this is a color map. Okay, helps me to understand how does the look, how does it look like. I can understand how throughout the number of days from Monday to Sunday, how the city behaves in terms of the temperature. Okay, that is what it means like. Next is bar chart, x and y axis is present. PLT bar x comma y, which means x, y. I have plotted the bar chart. I can just mention it as a bar and I will get a bar chart here. Okay, next is histogram. We have seen histogram in the previous lecture Numpy when we are discussing the statistic version of it. Basically means the frequency distribution showing the number of observations within each and every given interval. Okay, if you see here random number, I am generating a random number between 170. Yes, a random number between 170 and 170. So what happens is you get some values based on the histogram is being plotted here. This histogram is basically helps us to understand the frequency distribution of the values that comes out of this normal distribution of normal distribution of the random values that we got. Okay, next is pie chart. As we all know, this is pie chart. We have done a lot of things while doing mathematics. So if you see here, categories, transportation, these are all the expenses. These are all the expenses with each and every category, and defining the colors for each and every category. Okay, gold, light color. That way I've done it. And next is explode 0.1, which means I'm asking to explode only the second part. What does explode mean? This second part maps to this maps to this, and this maps to the rent. Basically, this second part exploding 0.1 value maps to the rent. If you see in the graph, this alone is separately exploded and shown here. That is what exploding means like. Okay, so that is what explode is. Figure 8,6. This is the size of the figure that I have mentioned here. I can change the parameters as much, and the graph that gets generated will be based on this figure size I have mentioned here. Expenses, which is basically this. Next is explode, the values assigned here. Labels is the categories that you know, and the auto PCT, which is the percentage. I'm asking it to mention the percentage of allocation for each and every category, so it does that value. Next is start angle, which is actually 140. The angle from this pie chart actually starts like. Okay, that is what 140 means. Title, as we all know, this is the title. And axis, so equal axis. And when I plot this, this is with respect to the aspect ratio, ensuring that the pie chart is drawn as a circle. Okay, next is pld.show prints me the complete pie chart. Okay, so hope you have a basic understanding and good understanding for you to start coding and do some small data analysis task with respect to the things that you learn from Python, Numpy, Matplotlib. So over a period of time, only when you start understanding, you will get to have more familiarity with each and every function that is available, and you will be able to analyze the data in much quicker duration. Okay, so this will be the last video of specific playlist, I guess. If you need something else along with the specific, or if I have missed something that you think I want to discuss about the library as well, please comment down in the comment section. Thank you for your time. Thank you so much. Please subscribe to my channel. Bye.